Hi folks, we're going to take a look at an example of sketching the graph of a linear relation given a described situation. Okay, so here we've got information about the cost of a party, okay, and it seems to depend on the number of people that are attending. Okay, so it tells us that it's $1,000 to rent the hall and then $120 per person for the meal. Okay, so the two variables we have, okay, so one error that sometimes people make is they could think of these numbers as being the variables, but these are given numbers. The variables are what changes, and the two things that change here are the cost, and it's given in the question. Okay, it's the total cost and the number of people. Okay, so here we have to determine which ones are dependent and independent variable, and I think in this case here it's pretty clear that the cost depends on the number of people. Okay, so first thing I'm going to do is I'm going to define my variables. Okay, so let x be the number of people or guests. Okay, and then y is going to be the total cost. And that's in dollars. Okay, so this is what we're working with. Now here, this $1,000 to rent the hall, I have to pay that no matter what. Even if nobody shows up to my party, I have to pay that. So think that that's the starting value for the total cost, or in other words, the initial value. So that $1,000 it actually represents my b value, my initial value, or my y-intercept. Okay, and here $120 per person. Okay, so that means every time I increase the number of guests by 1, the cost goes up by $120. So that's exactly the rate of change, or the slope. So m is equal to 120. And so my equation can be written as 120x plus 1,000. Okay, so there's two ways in which we can sketch this line. Okay, so in the previous video I used 1 point and the slope and thought of that as rise over run to sketch that. So here the point that I know could be that y-intercept, so 1,000 as being my y-intercept can be interpreted as the point 0, 1,000, and then I can use a slope. Okay, the other way is to find 2 points on this line and sketch it that way. Okay, so since I've got the equation here, I'm going to do it in a different way this time. So 1 point on the line makes sense to use 0, 1,000. Okay, now I need a second point on the line. Now I could use the point where x is equal to 1 and then calculate the y value. Okay, so that would make sense, make it nice and easy. However, I got to be thinking that if I'm having this party, I probably don't, and I want to use this graph to help me determine the cost. Okay, I'm probably thinking that 50, 100, 200 people might be at this party. So it doesn't make sense to have my graph going up by 1 person every tick. Okay, so I'm going to do it a little differently here, and I'm going to assume that for my second point, say I've got 100 people at this party. Okay, let's calculate the y value. So how do I do that? Well, I use the equation. So y would be equal to 120 times 100 guests plus 1,000. Okay, so 120 times 100, that would be 12,000, plus my initial value of 1,000 would be $13,000. Okay, so when x is equal to 100, the y value is equal to 13,000. Okay, and these are the 2 points I'm going to use to sketch my graph. Okay, now in this scenario here, since my variables represent cost and number of people, I'm never going to deal with any negative values. Okay, so this is where I'm now going to draw my axes along the sides of my Cartesian plane, since I don't need to worry about any negative values for either x or y. Okay, unlike the last graph I drew where I did have to worry about negative values. Okay, now here, since I'm going to be going to at least 100, okay, I'll think it makes sense for my graph here to go up by 20, say. So 20, 40, 60, 80, 100, okay, 120, 140, and so on. I don't have to go all the way around. The important thing is to show what my scale is. Okay, Now if I look at my y values, I have a lower end y value of 1,000, and my second point is going to be at 13,000. Okay, so this is where I want to choose the scale on my y-axis carefully. Okay, so I don't think it makes sense to try to go up to 1,000 and somehow get to 13,000. So this is where we can use our little trick of using the squiggle that allows us to skip a bunch of numbers if it's convenient for us. Okay, so I'm going to skip and go directly to 1,000, and now from here I'm going to choose my scale to go up as I need it. So it doesn't make sense to go up by 1,000 every time. Okay, otherwise there's no way I'm going to get to 13,000. Okay, so let me go up by 2,000 every time. So by using this symbol, it allows me to skip straight to 1,000, and now I'm going to go up by 2,000 every time. Okay, so this is going to be 3,000, 5,000, 7,000, 9,000, 11,000, 13,000, which I need, and then 15,000, and so on and so forth. Okay, so now that I have my scale chosen, I can plot my 2 points. So when x is equal to 0, y is equal to 1,000, and then when x is equal to 100, y is equal to 13,000. Okay, and now that I have my 2 points, I can carefully draw my line joining the 2 points. Okay, and I can use my little arrow here to indicate that this can keep going if I have more and more guests. Okay, but notice how I don't draw the arrow on the other side, because it doesn't make sense to have a negative number of guests. Okay, so again, this is a good indication as to why we call the y-intercept the initial value or the starting value. Okay, so that's it for this one. So just to recap, so when you're given a scenario, first thing you have to do is determine what your variables are going to represent. So you have to determine which is going to be your independent and dependent variable. Okay, if you can, write an equation. Okay, and then to sketch the graph, you can determine 2 points and join those 2 points. But try to think of what would be a reasonable scale to use given the scenario. So here it didn't make sense to have our x values going up by 1 guest. Okay, so here we chose to go up by 20 guests each time. And if you're going to skip a whole bunch of numbers to make it more convenient, be sure to use your